and welcome to the third webinar of the series of webinars organized as National Technology Day celebrations of the year 2022. And today we have with us Dr. Ajith V. Pai, a very distinguished speaker, and he'll be taking us through electric vehicles and their energy management. Dr. Ajith V. Pai is a graduate from the University of Kerala uh, in the mechanical stream of automobile engineering, and he has worked with many companies and institutions. He started his career journey at the Kerala's own Kerala Automobile Limited in gearbox design and performance calculations. And later on, he moved to multinational companies such as TVS, AVL, Ford, Cummins, and presently he is with Jaguar Landrover UK. And he's in the area of battery electric vehicle and hybrid electric vehicle control design. And I invite Dr. Ajith V. Pai to take over and have the technical talk. At the outset, I also thank Dr. Ajith for accepting our invitation and coming over to deliver a technical talk on a very contemporary topic like electric vehicles, because we have, the sales and services and everything of electric vehicles has just begun in India and especially in Kerala. So it's high time that we know about these electric vehicles and the technologies associated with. So I invite Dr. Ajith for taking over the session. Thank you, sir, and over to you.
Thank you, Dr. Shireen, for the kind introduction. So let me share my screen. I will stop my video and then share my screen. I hope you can see my screen now. Can you see my screen, Dr. Shireen?
Yes, sir. Yes, sir. You can
Okay.
move to the presentation mode, sir. It's not in presentation mode right now.
Yeah. Is it okay now?
Yes, perfect.
Okay, great. Okay, so let's start. So this is a topic about hybrid vehicles and energy management and its energy management. So I will show the basic structure of the presentation, what I'm doing. So as an engineers, we know that we need to, in the contents, actually, we need to see why we are doing any activity and what we are doing to solve that activity, that why question, and how we are doing. So so this structure, presentation structure, is based on that. So let me share. Let me take a laser pointer here. Yeah, okay. So you know, any MD or CEO of a company, they come and show the trends. They have some say on uh, the what product they need, and then as engineers, we need to look into all of that, and mostly we will work on this area actually. So that means our contribution to the whole product is quite high, because as we know, devil lies in the details. So we have to work hard to get the product right. So the trends is the why part of it, why we are doing any hybrid vehicles, and what we are doing is here, and then how we are doing it's here. Yeah. So basically, I will show the trends and then introduce you to electric vehicles, just show the basic construction, and then I will go into energy management from slide 15 onwards, halfway through. Then it becomes more technical, but what I will try to do is I will try to be more engaging with you. Maybe I will show you, use some pictures and engage with you to communicate well. Okay, let's start. So as Dr. Shireen said, I am working in Jaguar Landrover and working in the vehicle supervisory control team. So vehicle supervisory control is like an orchestrator of an orchestra. That means the automotive will have a lot of controllers there, like motor, engine, and maybe vehicle motion. So the vehicle supervisory control or coordinates the flow of control for all these controllers. So it is like it's like an orchestrator combining many instruments into producing a music. So the music in this analogy of music, in this case, it is the vehicle traction, vehicle motion. So I will be speaking more about a vehicle traction aspect of it. That is how the vehicle moves, and about that, not about the other aspects like body engineering or anything. So this is about mostly about vehicle traction, powertrain aspect of it. Let's see the current trends. So as we know, electric vehicles are getting more important. It will take more sooner than you think. For example, 2 years ago in Jaguar Landrover car park, they made around 20 electric parking facility, and it was completely empty. I was basically, the people were wondering why that much electric car parking reserved area is required. But now if you see, it's almost full. So that means many people are buying those cars, and it's getting slowly prominent. So, and then JLR having a Jaguar brand electric only by 2025. So that is a plan. Yeah, please. Yeah. Are you telling something?
Sir, I think that was a disturbance, sir.
Oh, sorry.
You
Okay.
can proceed, please.
Okay. Yeah, you feel free to ask questions. I'm happy to interact. Then we have Ford to sell electric cars by 2030, all cars, and General Motors have some plans. Volkswagen. Yeah. And then I'm not boring you with the usual slides which we see based on pollution. We already know the pollution aspect of the IC engine, internal combustion engine vehicles. So I will just show the commercial aspect of it, and then and go into more technical details. So here, as we can see, the Europe is catching up. It's getting more prominent in electric vehicle sales. Overall, 450 additional electric vehicle models are expected, and it may Germany is set to overtake China. So that this is a bit old data. So I have more recent data about UK car sales. I will show you later. Then there are more emission regulations coming up in Europe and China. So it increases more trends towards EV. So that the electric vehicles reduce the emissions, and also we know that it reduces the fuel consumption to some extent. Then we know cities and towns start to charge polluting vehicles. For example, if you want to drive your petrol or diesel cars in London, you have to pay around £15 nowadays. So there is a zone around London called ultra emission, low emission zone, um, and that will it will if you want to enter around it, you have to pay around roughly 1,500 rupees per day just to enter that town. And not only London, there are other cities in the UK also adapting such things like Birmingham, and many other towns, cities adapting that. So that means people are more encouraged to go into buy electric vehicles than using the petrol diesel cars. So that so so that is a slight push to the customers to uh, to buy electric vehicles, and also they are giving incentives in terms of free parking. So that also is a incentive to the pocket. And as you know, the petrol prices are high now, so that also is another incentive. And there is a trend of localizing supply chains, and also energy density. I will go into that in the next slide. And speed of charging also is a key game changer. So speed of charging I'm not shown as a slide later, but as we know, it won't take much time to fill the fuel in a car, in petrol or diesel cars. But if you for example, Jaguar I-Pace, you may have to wait for around 10 hours to charge it fully from zero battery capacity. So it takes a lot of time actually. And so we have to plan. If you are taking a long journey, then you have to plan where to park the car, and where to charge it, and all the things are required. There are solutions offered by the companies for that, but so there are some challenges as well, which will be overcome in the future. And energy density is a game changer for the that I will show you in the next slide, maybe. Yeah, this is a more recent trend in electrified car market share. So if you see how we can interpret this, the red, if you focus on the red lines, so those are the sales of electrified vehicles in the UK. There is a growth of around 88% for battery electric vehicles year over year. Market share of 14%. That means every 100 cars bought in 1 month or any time, 14 cars are battery electric vehicles. It's quite huge uh, prominence. So compared to the previous years, so previous years you can see there are very less presence in 2016, and now it is increasing. In April, the growth is not much, partly not because of any other effect of the electrification. It's because of the recession which is happening, which you may know. So generally the car sales are reduced, so that is reflected in the electric vehicle sales also. But overall, IC engine, internal combustion engines are a prominent one, and battery electric vehicles are still 14%, but which is growing into prominence. PHEVs, that is plug-in hybrid electric vehicles, so they are also growing, and market share of 6.7%. Yeah. Then yeah, so this is an important slide which I want to show you. Why we are bothered about cell energy density. That means the what hour is the energy capacity of the battery, how much energy it can produce per kilogram of battery. That means, for example, the best here is 300. That means that battery can produce 300 watt hour per kilogram of that battery. And as we know, the size, the weight of the battery or weight of any component on the vehicle is very important to reduce the fuel consumption. So if you have a heavier vehicle, we have less fuel consumption, and lighter vehicle, more fuel heavier vehicle, more fuel consumption, and lighter vehicle, less fuel consumption. So every kilogram is important. So to show you more about that, I will go into, maybe I will show take a picture and show the trend. Let's see. So that is new, and or I will go into Excel sheet here. Yeah, that is better. Maybe I will make it bigger. So let's see battery here. Maybe 24. Yeah, so that you can all see well energy density in watt hour. Sorry, watt hour per kilogram. Yeah, and then what we have here is the best is 300. So we need a 1 kilogram of battery energy to produce 1 watt hour of energy, battery size. So I think you can, if anyone know from the top of their mind, what would be the petrol's energy density? Before that, I will do a graph here just to add some dramatic effect into this discussion. So bar, yeah, okay. Select data, edit. Series name would be this one, and then the data we want to present is this one. Okay, that's fine. So we have only the batteries. Yeah. So sorry, not diesel. It is the hydrogen. Okay. So can anyone know from the top of their mind what would be the petrol's watt hour per kilogram? That means you have a fuel tank in your car, and if you fill up 1 kilogram of fuel, petrol, 1 kilogram will be lesser than the 1 kg, 1 liter, maybe 0.8. I don't know exact density of the petrol. How much would be the energy density? I will, yeah, it will be around 12,200 watt hour per kilogram. So you see the difference. So the battery is here. Battery is very small. So that means to produce same amount of energy, you need that much kilogram of battery to reach there. So that difference you can see here. The number 2 is the petrol, and hydrogen is even better, which is my which is getting more prominence as it may get more prominence in the future, because if you have a fuel cell car, that means which is powered by hydrogen, which is 3 times than the petrol's energy density. So you don't need, the implication of this is you don't need to increase the size weight of the car to get more energy out of it. So so this is an important thing which we need to focus. And the basic equation for traction. So that means if you want to, if you consider other things remaining same, the force to propel the car is proportional to mass times acceleration, which is told by Newton. So mass of if you increase the mass, the force also will go up. That means we need to spend more energy to drive the same amount of vehicle's weight. So this calculation is important. So battery is still not the great thing, I would say, but it is a important step towards going into hydrogen or better and energy density products. So the basic fundamentals which I am going to show you will be applicable for hydrogen as well. So it can be applied there, and it is relevant. Okay, let's go back to the slide. Can you see the slide, Dr. Sharif?
Yes, sir, we can.
Okay, thank you. So that we have seen the cell energy density. So for example, we need so the typical battery pack of around Jaguar I-Pace would be, so Jaguar I-Pace, I would say here, Jaguar I-Pace, which is an electric vehicle. Weight is 600 kg, yeah, and energy density is 100 kilowatt hour. So the sorry, the energy, not the energy density, it is the energy capacity. So energy density is nothing but 100 over 100 times 1000 to make it to watt. 100 times 1000 divided by 600 kg. So 167. So we need a 600 kg weight of battery to propel the car. That means around 10 people's weight, roughly, if you consider one person's weight as 60 kg. So it is equivalent to you are driving a car with a 60 people on top of it. Of course, I have not removed the, you may argue, the I-Pace doesn't have the engine, so it may be lighter. Yes, I had to remove that an engine's weight from that to get a more representative figure. Yeah, and then of course you will have more motor weight added to the car. Okay, so let's see. So here the price is also important. We don't have a lot of money to buy just for the sake of environment. It is not a great incentive for people to buy. Of course, there is a principle involved. We have to reduce the carbon footprint, but we have to see our bank balance as well to buy a car. So the battery pack has to be lesser price as well. So it should reduce by, and there is a decreasing trend as the time goes. Okay. So that is it about. I hope you don't have any questions. You can ask questions anytime. So that is fine. And then I want to show you what is the choice we have. So that means what are the types of vehicles we have in different levels of electrification. So as you go from the combustion engine, very less electrification, but fuel cell, which is the ultimate electrified one or electric vehicle. So as you go from left to right is the increasing trend of electrification. And as you go from left to right, you will have more battery capacity, battery capacity increases. And and then combustion engine, the engine's dependency reduces and motors dependency increases. Okay, so you have here micro hybrid, which is very small electrification. That means it will have a small motor, higher combustion engine, and it can do a limited things like it can stop and start. That means if you are stopping on a traffic, it can stop the car and engine and then start the engine when it is ready to move. That means you can save some fuel. Limited region braking. Region braking is a term because when you press the brake pedal, the motor becomes a generator and it charges the battery. So it has less capacity because the motor capacity is smaller. Then we go to mild and medium hybrid. You can start to idle and then full some more amount of region braking is there. Engine assist is there. That means the motor can assist the engine to propel the car. So it is not only the engine, it's some extent motor also helps, but it's very limited actually. It is in the mild and medium hybrid. If you go to full hybrid, which is plug-in hybrid electric vehicle or hybrid electric vehicle, the engine can again stop and start. It has a good region braking capacity. Engine assist is very good because motor size is high, battery size is high. You can give more power to the traction in addition to the engine. And it can also go into electric only mode. So for example, if you go as I said before, if you go into London with this type of car, and the car can automatically detect that it is in the low emission zone based on the data coming into the vehicle, and it can automatically switch off the engine and run only in electric vehicle mode. That means it won't be polluting the cities as it was before using conventional IC engine cars. So that is a good feature, electric only mode. It can save some money in terms of not paying the low emission zone charges. So that is also a good advantage. And when you go to electric vehicle, it's only battery and motor, so no engine at all. So we have to charge the battery by external battery electric sources, or using region braking. And fuel cell is, you have a good size of fuel cell replacing the battery, which we have seen in the previous chart, and a very small amount of battery size there, and just to assist. And then it is electric only, no engine at all. So that is the future going to happen. And if you go to the right, the cost of vehicle increases to do all these things. So we have to uh, at the at the present condition. In the future, it may reduce. Yeah. So just to introduce the electric vehicles, we have a Jaguar I-Pace here, and power source is high voltage battery pack. This area here. So below the passenger seat, there are many battery packs, 600 kg weight. It produces 90 kilowatt hour of energy, and actuators, which are motors on the front and rear axles. So here you can see they are motors, and they can produce in total of 700 Newton meter or 400 HP. And energy recovery methods are by regeneration during acceleration. So for example, if you drive the car and you remove the throttle, that means you don't accelerate, the motor becomes generator and it charges the battery. These orange lines wires are all high voltage, around 400 volt power lines going into the motor and back and forth. So they are very high voltage systems, 400 volt. And energy recovery methods are regeneration, as we have said, and also we can charge using electric mains. So when you come back home, charge it to the electric mains, and in the morning it will be ready. And I just want to introduce into energy considerations also for this I-Pace. So our objective about the electric vehicle is to maximize the range. That means how much kilometers we can cover of the vehicle by the vehicle for a single charge. So it is influenced by the speed actually. So if you go into city condition, it could be around 27 kilometer per hour. These are all European conditions actually. And if you go into highway, average speed would be 92, and combined average speed of both, if you say, it will be around 47 kilometer per hour, because we are interested in combined speed. And then, so to represent that, we have a drive cycle which is used. I think in India also we have a similar drive cycle which combines everything. So this drive cycle is nothing but you take the car and test the car in a dyno where there are rolling roads available, and you drive the car at different speeds, and this is the time and speed, and you simulate the city condition in this region, 27 kilometer per hour average around, and then motorway or highway, all these things. So it is around 47 kilometer per hour, 92 kilometer per hour, and overall average is 47 kilometer per hour. So you have a lot of various acceleration, decelerations involved here, which will uh, which will which will simulate the actual vehicle conditions in the actual real world road actually. So that is a drive cycle which we have to see. So generally, when you see a spec of the car, this much fuel economy, maybe 18 kilometers per liter, um, or some kilometer per liter under standard driving conditions. So they mean this drive cycle. So they drive the car in this standard drive condition at right temperature and right speed, and then see how much fuel economy is used by the car. So that is irrelevant for the electric vehicles as well. And wheel sizes have an influence on the vehicle's range and electric loads. For example, you drive an I-Pace and you switch on the AC. So the vehicle has to work harder now. It has to propel forward, and also it has to run the AC motor and everything. So it will consume some energy. So that will reduce the range. And ambient temperature, colder temperature, lesser range. And can anyone tell me why colder temperature, lesser range for electric vehicles? Okay, so the colder temperature means the battery temperature will be lower, and the resistance of the internal resistance of battery will be higher, and hence it will lose a lot of energy internally itself, and hence we can't get much range from the battery. So that is one aspect. So that is important in European conditions. And how to improve the range? So we know brake regeneration. We can lift off the accelerator pedal. That means if you lift off the accelerator pedal, vehicle will slow down and it will charge the battery. Driving style, smoother driving style is better, and we can precondition the battery prior to driving. That means we can raise the temperature of battery even though it is cold outside, and hence it can give more performance. And there are active vanes, which I may not have much time to show that, but these are vanes on the front of the car which can close and open based on different speeds. So if the vanes are open, that means more cooling to the motor. And now we can go to the hybrid electric vehicles. I think we are halfway through the presentation. In the hybrid vehicles, so we have 4 types broadly classified: series hybrid, parallel hybrid, series and parallel hybrid, and complex hybrid. So just to make it more illustrative, I will take the picture of this. Yeah, series hybrid means, so you have an engine here, you have a motor here. So these are 2 actuators to the wheels. So this is wheel actually. So the transmission is connected to the wheel. So I would say it is wheel. So here, as you can see, there is no connection between engine and the wheel. It is disconnected, but the motor is connected to the wheel. So what the engine is doing is it's taking the fuel tank fuel, petrol, diesel, basically petrol, because diesel we don't need a. There is no. You might not have seen any diesel hybrid electric vehicles, maybe very less in the market, because diesel as such it is good fuel economy. So no incentive to make that into hybrid. So engine is running. It runs the generator, produces power, and there is a power converter or inverter. It could charge the battery. Engine can charge the battery, and battery can in turn through the power inverter uh, run the electric motor transmission. So that is the way. So engine is just to charge the battery here. In terms of parallel hybrid, both engine and electric motor. So this is the engine, this is the motor. Both are connected to the wheels. That means engine can use the fuel tank, run the wheel, and also battery can use the electric motor to run the wheel. Yeah. Uh, so here both the speeds of the engine and motor has to be same because it is coupled to a same wheel. It cannot run at a different speed and this cannot run at a different speed. It has to be same speed. But the torque output of the engine and the motor can be same. No, can be different because power output is a function of torque and speed. So speed is same, but torque can be variable. In terms of series parallel hybrid, this one, number 3, there is an engine, there is a motor. We are happy with that. In addition to this, what it does is it also generates power and gives to battery. So battery is charged by that. So here battery has to be charged purely by external AC means. But here we can the engine will charge the battery while running the car, which is more good. So it also will have a plug-in hybrid. Plug may be there, but the engine will charge the battery, and electric motor will be operated by the battery, and then we get the same function as the parallel hybrid. This is more complex. I think here we can it can move into a generator and electric motor mode, which I'm not going into more details. So we are more interested into this series parallel hybrid vehicle in this presentation. So it can be how it can be applied to hydrogen fuel cell. So if you just simply remove this, simply remove this IC engine, and put a fuel cell there, it becomes a fuel cell vehicle. So it is directly applicable to the fuel cell. So I'm trying to form a groundwork here for the fuel cell. Yeah, so this is a series parallel hybrid vehicle. Fuel tank gives power to the engine. Engine gives power to the mechanical coupling. Then we have a battery. Battery charger. We can charge the battery from external plug points. Battery will run the motor controller, and through motor, it can give the power to the mechanical coupling and then to the wheels here. So, and also engine can charge the battery using mechanical coupling. Engine can charge the battery using mechanical coupling, motor. So while charging the battery, it goes through the motor controller, and then to the battery. So there are complex mechanism happening. That means there are different modes of operation. Which means there could be engine only mode. Engine alone can drive the car. There could be electric only mode. That means motor alone can drive the car in low emission zone maybe. There could be combined. That means engine power is not sufficient, or motor power is not sufficient. Then they both work together to drive the car. And there could be engine charging the battery mode. So that means engine is driving the wheel plus it is charging the battery. So that could be another mode. There could be another mode where the wheel is when you drive the car at a high speed and then remove the accelerator pedal, the wheel will be driving the car. At that time, the battery will be charged using the motor again. Yeah. So there are several modes of operation. So which makes it more complex. We have to coordinate different actuators, which is the engine, motor, and then we have a battery to look into, and then so all these things are different actuators are there. So it involves more complex logic control algorithms. So I think we have gone through this. I will just go through this briefly. This is a Range Rover Sport where we have electric motors in both axles, but engine also is there. This one is the engine and motor on the axles. Here we have engine in the front, and it drives a orange wire, if you remember, at a high voltage 400 volt. It can drive the motor at the rear. So this is in Range Rover Evoque and Discovery Sport. So this is a mild hybrid electric vehicle, which is not a plug-in hybrid electric vehicle. That means you have a very small 48-volt lithium-ion battery, very small capacity, and it can do some sort of assist. It can start and stop. It can, yeah, such small things it can do, but it's not a major hybrid uh, architecture. Then we have a plug-in hybrid electric vehicle. So we have now the battery capacity is increased 13 kilowatt hour compared to the mild hybrid. If you remember, for the electric vehicle, it was 100 kilowatt hour. So it is quite high. With 13 kilowatt hour, you can drive maybe for 30 miles just with the battery. But so that means it has to have an engine, and they will both work for better traction and all the things which we have said before. I hope no questions. So I'm slowly moving into energy management now, because everything is energy, and energy management is the key feature where uh, the why we are doing hybrid electrification is coming into picture. That means we just don't want to do extra work, because we have a lot of engineers working just by putting battery motor in a vehicle. IC engines has worked for many years without any problem. The industry is mature. Then why we are doing this disruption of electrification? That is because energy management. So that means we can reduce the fuel consumption and also reduce the pollution. So that is the main driver. Otherwise, we don't want to change anything. We are happy with the IC engines. So in a typical IC engine car, which is internal combustion engine car, so the driver will operate an accelerated pedal or a brake pedal. So that's it. He does that's it, and he can change the gearbox. So it is just 1 degree of freedom. That means he just changed the gear ratio to drive the car. But in hybrid electric vehicles, if I go into this slide, in hybrid electric vehicles, the accelerator pedal, it not only operates the IC engine, it has to operate the battery or electric motor. Yeah, so we just single pedal as a to operate two actuators is not enough. So we need two, but we can't have two actuators. So what we are having is we are having a control strategy, which is explained here. I will show you in a better way. So we have a energy management system, and we have only one throttle pedal from the driver here, only one throttle pedal, accelerator pedal. But then it gives a demand to the energy management system. Look, to meet this speed of the vehicle, don't worry about all this subscript. Just this is the speed of the vehicle. To meet this speed of the vehicle, I need this much power. There is a calculation available here. And what the energy management does is it takes the total power required, it splits into two. Okay, you the IC engine, you give this much power, and the battery, you give this much power. So it splits into two. So that is the main function of the energy management system. And then you have a low level controller which will take this power and then uh, says to different actuators such as engine or a motor to deliver that, and it will have a continuous feedback. So the vehicle is moving forward, it will feedback the speed here, actual speed, and this is the required speed, and it will find the error and it will correct the driver power demand, and energy management will recalculate. So this is the basic traction activity of the car. And also it has to consider the energy management in addition to the power demand by the driver. It also has to consider the state of charge of the battery. State of charge of the battery is nothing but you might have seen in your cell phones. The battery is full, So that means 100% state of charge. And in your cell phone, if the battery is small, less, it could be 20%. So energy management considers all the state of charge of the battery, and then it will vary this power split or the torque split from the engine or the battery. For example, if it is 20%, it knows that it can't ask too much from the battery, because battery is already in bad shape. It can't produce the power, so it has to ask more from the IC engine and less from the battery. And at the same time, it has to use the IC engine to charge the battery. So it is a clever logic. It does all this arbitration. Any questions on this? Okay, so I hope this basic control structure is clear. And then if I go, let me see what to say about this optimization. Yeah, I think I can skip this slide because we are nearing to the end. So I will show this quickly. So energy management, what it does is it will use a cost function. That means this is the fuel economy curve, and it will find a smallest fuel economy point for the car, and it will ask the power from engine based on the smallest fuel economy point from the current calculation, and it will ask power from the engine and also from the battery. So there is a cost function here, which means to reduce and the goal is to reduce the cost function. So I won't go into more technical details. So these are all energy management, are different types of energy management, and we have a rule-based and model-based optimization. What we do is basically combine both and deliver to reduce the fuel consumption. Then I will skip this one. Yeah. So energy management, I will show in a different picture here. So energy management, while doing the energy management, what it does is it will have constraints. That means the for the current time, it will see how much battery can provide power, whether it is within the limits, and how much engine can provide the power. It will see it has limits. It can't be exceeded, and also it will see the state of charge of the battery. If the state of charge of the battery is high, it can ask for more power from the battery. If the state of charge is low, it can ask for more power from the engine. So that is the consideration energy management will do. And then at the end, it will see how much fuel consumption is reduced. So how much fuel consumption can be reduced by combining these two. I can give you a more illustration here. So when energy management, what it does is it will calculate the equivalent fuel energy at a given point of time by adding the fuel required to drive the car, and also it will consider how much electric energy is required to drive the car. But electric energy we cannot directly convert into fuel energy, equivalent fuel energy. There is a conversion factor required. Why that conversion factor? For example, if you use this analogy here, if you think the fuel tank is a bank, and this is you, and this is something you are going to buy, and the conversion is the interest. So if you want to buy some goods, that means vehicle is moving forward, either the engine or the electric machine can provide the power. So in this case, engine is you, where you have a money in your purse or a savings account. But if you want to drive the vehicle, that money is not sufficient. So you take it from the fuel tank. You have to have an engine, and then you have to convert that engine's power into electric machine's power using the battery. That means this electric machine will become a generator, but you can't have anything free of cost because there will be losses. So that is where the interest happens. So you end up into paying into bank the same amount higher than what you borrowed initially. So that is the interest. So there is a conversion factor. It's nothing but that interest. So electric energy has to be multiplied by some interest to get the actual fuel. So nothing comes for free. We cannot say that we can just drive the car in electric machine only, because it will take some energy, extra energy in terms of efficiency. And at the same time, there will be another logic. When the vehicle is driving the wheels are driving the vehicle, you are getting some money from outside. It will go some extent, it will go into bank. While if you deposit that money into the bank through the electric machines battery, uh, then again you have a efficiency for battery discharge. So there will be some taxes to pay. So that also need to be considered. So that means if you use the electric machines to drive the car and to charge the battery back, you need to spend some extra money, extra energy to do the equivalent calculation. So for the hybrid vehicle, we have to consider the fuel energy and also electric energy and the conversion factor to get the equivalent energy. And the energy management, what it will do is try to reduce the equivalent fuel energy at any point of time. So I will go into one case study. So this is which we have the motor torque limits, minimum motor torque and the maximum motor torque here. And you have the maximum power required by the car and minimum power required by the car. So this is a time instance, maybe for example t equal to 0.01 second. So that is one time instant when you are driving the car. And the energy management here, it calculates how much power we need to drive, we need to use in the use in the engine only mode for doing this value, for doing this power. And also it calculates how much power required to drive the using the battery only mode. And then it do a combined equivalent optimum result. It finds an optimum result. So as we have seen, our objective is to reduce the power. So at this point, the power consumption is lower for driving the car. So that means it becomes an electric only propulsion because the power of battery is lower at that point compared to the fuel. Yeah. So I think our time is going to an end. I've quickly gone through the slides just to reduce the complexity. But if you want to see one slide which you have to remember, maybe this is the one where different levels of electrification and different architectures which we have shown before. So that's all from my side. If you want to. We have seen types of power sources: IC engine, mild hybrid, plug-in electric vehicles, and electric vehicles, and the fuel cell electric vehicles. So those are the types of power sources. Energy consideration, we have seen how much range is required to be EVs energy range is important. Hybrid electric vehicles range is not much important, but we need to reduce the fuel consumption in the hybrid electric vehicles. Importance of energy management, we have seen, that is to split the driver's power into different actuators and at the same time reduce the fuel consumption. Classification of EMS control, we have briefly gone through, and there are issues in implementing EMS, so that we have seen briefly. And we have seen introduction to ECMS, which is equivalent consumption minimization strategy. That means the equivalent consumption of the fuel and to minimize that using an electric energy management strategy. So you are feel free to ask questions.
Participants, if you have any queries, please ask, sir, or you can even post it in the chat box.
Hello.
Hello, yes.
Am I audible?
Yes, you are, yes.
Yeah. I am Dr. Ajith Prabhu, Chief Scientist in KSCSTE.
Okay, hello.
Yeah, Dr. Pai. Yeah, it was a very nice presentation. I have a small doubt in the sense it's a practical. See, this fuel cell technology,
Yes.
I have been hearing about that for the last at least 3 decades, and I have done a little bit research also in the initial periods at Karakudi, that Karakudi Research Center also.
Mm-hmm.
Fuel cell. I am talking about fuel cell.
Yes.
But now I understand that it is, of course, already well developed, and even in US and even UK and many countries now, even buses are flying and cars are flying with fuel cells and all. But why
Yes.
it is not that much propagating in India? What is the impediment of propagation of fuel
Uh,
cell and fuel cell technology in India?
I think it is mostly about the tech acceptance because it's the as we said about the cost. Actually, it is high cost.
Cost. Okay.
Yeah. For example, Toyota. Let me see the price of that vehicle
Mm-hmm.
price.
So probably no, it may be like a socio-economic problem rather than a technical problem, right?
Yeah,
Technology is fully developed, even hydrogen storage and many things. It is developed.
Yes, yes. So technology is there, and
Yeah.
fuel cells are available. And I'm currently working in fuel cell project also. So it is under
Okay.
development. Under
Yeah.
development. But
Yeah.
only thing is in infrastructure. That means hydrogen filling infrastructure. It requires a uh, lot of infrastructure required. Let me find out. If you give me 1 minute, I will find out a slide. Um,
Yeah.
uh, hy- uh, I'm sorry, I can't find that slide. But basically, what it does is we have to have a fuel cell station, petrol pump, and kind of petrol
Yeah.
pump. The fuel cell
Yeah.
charge filling up the vehicle is quite fast compared to electric vehicle charging. But it requires internally, it requires a lot of conversion, like compressing and cooling the system, and then again compressing back to charge into the vehicle. So infrastructure is the main thing, and
Yeah.
hydrogen production is maybe a second uh, producing a green hydrogen that or the blue hydrogen they say
Mm.
without using much energy. That is another one. I think India, it is Reliance are all working on that to get
Mm.
into the more hydrogen mode.
Oh, oh,
ഏതാ?
oh.
Full
Okay.
ആയിട്ട്
Okay.
എടാ എനിക്ക്
Thank
തണ്ണീർ
you.
ഒരു സാധനം
Okay,
വേണമല്ലോ.
thank you for the question. And to add to that, I think still electric vehicles are yet to penetrate into the market, mainly because of the cost. I would say cost is the main driver because I have seen the price of Toyota's fuel cell vehicles price. It is around 63 lakhs in the UK. Maybe in India, while importing, it may be much higher unless they produce in India.
Okay. Okay.
It may be more than a crore.
Okay.
And it is quite difficult. So the cost has to reduce, and
Yeah.
yeah,
And maybe one more, just a practical question. See,
yeah,
the byproduct is water. See,
yes,
in vehicles, no, they are what they do with that water.
yeah.
Yeah,
It's a
it is just left in the road or collecting.
no, it is a good question actually. Yeah, what they do is the fuel cell stack requires some moisture, so
Okay.
the water is bypassed to make the fuel cell stack hydrated, if you say. So it is used in that way.
Okay. 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 Okay.
Yeah.
Okay. Thank you. Thank you. Thank you.
Okay, you're welcome.
Because I have done research during 1970, 96, 97
Yeah.
at CECRI, Central Electrochemical Research Institute, Karaikudi. At that time, it was in a very initial stage.
Yeah.
So I have visited that lab and done a little bit research in that. So it is my area, in fact, area of interest rather. So that's why I'm asking these questions,
E-
probably
ex-
practical questions, because so afterwards I have left the clutch. But now the technology is so advanced, but still why it is not dissipating in the society, propagating so that makes me unrest.
Yeah,
That
I
is
think
why.
slowly it will come. Even if you
Yeah,
see, there are hydrogen powered electric uh, v- planes are there actually,
yeah, yeah, yeah.
which are I have seen. I have visited a facility in the UK.
Mhm.
I think I can share my screen again. So let me see.
So primarily, number one, cost aspect, another two, infrastructure facilities are the two impediments for the propagation of fuel
Yeah,
cell vehicles. No.
that's correct. Yes. So you might have seen
So,
here that it is actually running. I have seen a flying plane, actually flying plane, which
uh-huh.
is yeah, with the hydrogen. They have in a facility in the UK,
Okay,
sorry, and they produce hydrogen in house and fill up the hydrogen into the plane and fly it.
okay,
They have a good plan also. They give a good case study why they are doing it. That means,
okay,
for example, you say carbon dioxide produced in the ground will cause problem in the ozone uh, above us. But if you produce carbon dioxide near to the ozone, it is more harmful. So the hydrogen could reduce that. Hydrogen vehicle can reduce that. It's purely hydrogen based. There is no battery. Purely hydrogen is converted into fuel cell and then run to propel the engine, both engines. Yeah.
now, does it use air breathing engine to generate separate and generate hydrogen and oxygen, or
Uh,
hydrogen alone is carried? How it is done?
yeah, the hydrogen is
They carry hydrogen.
yeah, manufactured in the ground using
Okay,
solar
and
power.
oxygen probably harnessing while traveling, I think, right?
That's correct. That's correct. Yes, yes. Oxygen is
Okay,
from
okay.
outside, so there is a
Oh,
compressor to give the right amount of oxygen.
yes,
Yeah,
yes, yes, yes,
yeah.
yes, yes. So they need not carry oxygen, but only hydrogen. Huh?
Only hydrogen. Yes.
Okay, 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 fine. Thank
Yeah.
you, thank you, thank
You're
you so
welcome.
much.
You're welcome. Yeah, maybe we can keep in touch if you have any research interest and yeah, any discussions required.
I will get your email ID from Dr. Shereen. We will be in touch with.
Oh,
Thank you.
okay. Thank you.
It is my fascinating area.
Yes, it is. It's the future, I would say.
Yes,
Basically this
yes,
consideration, if you see the battery energies, we need to add lot of weight into the car to get the equivalent hydrogen's energy.
yeah.
Yeah, so that makes it a future technology actually. And people are working on hydrogen combustion engines also. So that could be another interesting one.
Yeah.
In
Moreover, I have read somewhere once you calculate the embedded energy for the for manufacturing of battery and well as other hydrogen system. This is here battery system it is more.
yes, yes, absolutely, absolutely yes.
Yes.
In
Thank you.
in the future, we may have even houses, no, outside. There could be hydrogen generators. We use that hydrogen for cooking or some heating the
Yeah.
house. So
Yes.
that kind of things will happen, especially in this Ukraine war when the natural gas is in hard supply. So
Mhm.
these kind of technologies may accelerate,
Okay. Okay.
and
Okay.
nuclear also may come into future. So that
Okay.
means we can have a cheaper energy to charge the battery.
Mm,
And
mm, mm,
I think I've not shown you one slide which I wanted to show. This is the present condition. So 11:20 is
mm.
the time in the UK. Okay,
Mhm.
12, it is 12:30, and you can see here. This is the total energy produced in the UK, and the wind is the major one now, 41% compared to
Oh.
coal and biomass, yeah, or other source of energy. So wind is
Oh.
much. So that means it is quite clean energy. So
Okay.
there is no carbon dioxide emitted while doing that.
Mm, mm,
So
mm.
that can be used easily for charging the battery, running this hybrid or electric vehicles. Uh,
Okay.
yeah. So that is encouraging because people can ask. Okay, that is fine. We are charging the battery using a high from the battery mains, but how that energy is manufactured? Maybe it is from the coal station, but with the more renewable energy coming up, like wind, nuclear, we will have good solution in the future.
Okay, 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 okay. Okay, okay,
Okay,
Dr.
okay, thank you.
so
Any other questions?
I think there are no more questions. So can we wind up, sir?
Yes, yes, thank you.
Thank you, sir. Thank you for taking us through an interesting journey on hybrid vehicles, and thank you for introducing the concepts of energy management very gently. Thank you for explaining the concepts in a very simple manner, and unlike many other speakers that we have seen, you have taken the pain for taking an Excel sheet and entering data and showing the real graphs and how they differ, all those things, and taking another uh, blackboard and showing how what points in the graph points to what it signifies. And thank you for taking the pains for explaining it through a blackboard kind of thing also. So thank you for sir, thank you for joining us. So I hope we'll have more associations in future. Thank you, sir. I hope you enjoyed the talk. Thank you.
Thank you. Yes, I very much enjoyed the talk. Nice interacting with you all.
Uh, and I request the participants to join us for the fourth webinar of the series, webinar series on Monday, same time, 4 p.m. to 5 p.m. The webinar will be led by Dr. Suresh, and he'll be taking us through social entrepreneurship aspects. So I request all the participants to join us on Monday, same time. So wish you all a very good weekend. Thank you.
Thank you.